The last compound transistor we'll look at is called a CzilkaiPair. So like the S isn't there, Zilkai. And it looks like this. This is the NPN version. So you can see the collectors on top, emitters on the bottom, base is on the base. And this has the same beta characteristics of a Darlington pair. And let's see why that is. So let's say we decide to ground the emitter and we take this as your Vin, and then you look at the current going through here. What happens is if you change Vin, that changes the VBE of Q1. So that turns up the current a lot. So IC gets turned up. Where that IC comes from is actually from Q2. And so remember for PNPs, the current comes out of the base, not into the base, since all the PN junctions are flipped. So current's coming out of the base, so that's your IB. So what happens is if you consider IB1, so you have IB1, IB1 coming into Q1, so that means that IC1 is beta, IC1 equals beta IB1, and that's the current coming out of the base of the PNP, and in the exact same way that's NPNs, when you put on IB into the base of a transistor, the current coming out of here also gets multiplied by beta. So the IB2 leads to IC2. Yes, IC2. This represents, even though this is the emitter of Q2, it represents the collector of a CzilkaiPair. IC2 equals beta IB2, and IB2 is IC1. So what you get is beta squared times IB1. So you get that same beta squared advantage. You get lots of current. So this is very good for an output stage. But if you look at the collector, since it's on an emitter, and just a little change in if all of the rest of the voltages stay the same, a change in the collector voltage changes the VBE of Q2, and the current changes a lot. So it actually has a small R out. Okay. So it has a small impedance seen on both sides, because when you change this one, now you're changing the VBE of Q1. If you change the collector, you're also changing the VBE of a transistor, but it's Q2. So both of those give low impedance. And let's see, Rn just goes through a single transistor, so your Rn is still R pi. Your current gets multiplied by beta. Your VBE on. So remember, one of the weaknesses of the Darlington pair was to turn the transistor on. To turn the compound transistor on, you needed 2 VBE. You needed a VBE on and then another VBE on. And for this one, you only need a single VBE on to turn it on. So now you have a wider input swing, because before, if you're going up from 0, you had to go to 2 VB on and finally it turns on, and you're in the amplification region. And you've wasted some voltage here, just getting to the point where the transistor turns on. So this one turns on earlier, so you have a wider range of inputs that you can use. This also, again, has the same VCE sat. So you have across Q1, for Q1 to be in the forward active region, you need a VCE sat across Q1. So if you're starting here, you go up a VCE sat, and then to get to the collector, you go up a VBE on. So that if you're following the path here, you're going Q1 and then up the VBE of Q2. So you still get a largest VC sat, so that might mean that you have to turn up the supply voltage. So superpower is a lot of current, so it's really good on the output stage. It's VB on being smaller than a Darlington isn't a superpower. It's just it gives you, it's the same VB on as a single transistor. The cost is you get is this right here. You may need to have a little higher supply because you need V2 VB on plus VC sat across your compound transistor. Okay. So that's all there is for the CzilkaiPair for BJTs. For MOSFETs, again, if you try to imitate how CzilkaiPairs are implemented in MOSFETs, so this would be the drain, the gate, and the source, you're not going to get anything because no current's going to come out of this transistor. So again, very often you see like a resistor here, and then as you turn up the current here, it moves this node, which changes your VGS here. Like if you pull more current through this, now you've got more current going through this resistor. The difference in these two voltage, which is VGS, goes up quite a bit if this resistor is of any size and turns up your current. But it's not the same mechanism as the CzilkaiPair for BJTs. But again, this is great for an output stage just because it can supply lots of current, so you can connect up to any circuit. If the circuit that you connects to asks for current, this thing can provide it for you.